Hey Adi, how are you? I'm good. What about you? I'm also good. Actually, I'm facing a problem. I am writing an article and I want to check the AI content for the article, but all the tools which are available are paid. Can you find a solution for that? Don't worry, Arun, I will make one for you to check the AI content using machine learning. Oh, that sounds interesting, but how would you make with the help of machine learning? That's simple. I have a dataset which contain human-generated text and AI-generated text with the labels as 0 and 1 representing human and AI respectively. So basically this a supervised machine learning problem. I will do some text preprocessing such as stop word removal, common occurring word removal etc. In my previous video I have discussed a word embedding technique called TF-IDF. With the help of TF-IDF, I will convert text data into numerical data and apply machine learning algorithm on this to train the model. So, let's go to the computer screen and make an AI detection tool.
Hello friend, I am Aditya and welcome you all in my YouTube channel. And I hope you are all good and doing great. And I hope you must have watched the conversation between my friend Arun and me. So basically, he is searching for a tool which can detect AI content, and almost all the tools which are available are paid. So I said to Arun, is don't worry, I will make one for you. So, and today in this video, we will be building an AI detector tool together for Arun, and we will made a UI for it. For this project, you should have some basic knowledge of machine learning and Python. So let's write code to build an AI detector. So for this, I have made a folder named AI detector, and I have a CSV file in this folder, which is AI human.csv, and this CSV contain and this CSV contain AI generated text and human generated text, and corresponding to these text, I have given some labels. So basically the label corresponding to human generated text is given as 0, and the label corresponding to AI generated text is given as 1. So I will let's open it code editor. I will open uh, VS Code. So in this VS Code editor, I will create an IPYNB file. So let's name it as main.ipynb. So this is my IPYNB file. Wait for creating the file. Here is a file created. So main.ipynb file. So this is basically a Jupyter notebook, and I have installed this by installing the extension from here, Jupyter notebook. You can also install it in your VS Code. So let's import our modules and libraries which we will be needed. So let's import. Let's import modules, importing modules and library. So let's first import pandas, which is pandas for reading the CSV file, and import numpy for numerical computation. Numpy is NP, and for visualization, I have imported matplotlib.pyplot as plt, and last import keyboard as snx. So this is the modules which I have import initially. So if you have not install any of these modules, so you can write pip install module name. Like if you want to install pandas, so you can write pip install pandas in your command prompt, and run this pro, run this run this command, and pandas will be installed in the system. So this is the basically a command. So let's run this cell. So in let's at our Python environment. So this is our Python environment 3.1.3.10.0. So these are the modules I have imported. So for pandas for reading the CSV file, NumPy for numerical computation, and matplotlib for visualization. So this is our file is running. So let's read the data. So reading the data. So PDF is equal to P. We will make it a PDF variable and read the data. Read CSV. So our file is ai human dot CSV. Let's print some value. So df.head. This head function this head function prints five rows of the data default by default. And if you want to print for let's say if you want to print 10 number of rows, so you can print it by so you can pass 10 in this, and then 10 rows 10 rows will be printed. So I have basically printed only 5 rows. So df.head, it will be taking some time. It is taking some time. Why? But let's see. So here you will see that I have printed first 5 rows of the data. So here is a two column text and generated text our features and generated our class variable which we are going to predict. So this is the text. Car have been around since they became and dot dot dot. And if you print the whole text, let's say df and text 0. Let's say I have printed zeroth index text. So this is our text. And this is our whole text like this. And the cars have we built cars have played a major role in every day. So this is our text, and corresponding to this text, the label is 0, which is showing that the label is human generated. And suppose if you print if you will if you print and if you want to print the human AI generated text. So I have told you earlier that for AI generated text, I have given label as 1. So and if I print df and I will be selecting generated equal to 1, and I am selecting text. So this is our text, and let's run this cell. So this is the log value 704, 704, 740, 1262. These are the values present at and if I print the index value 704. So with the help of block function, you can print 704 index. So this is the text. This essay will analyze, discuss, and prove one reason in favor of keeping the Electoral College in the United States of the presidential election on one of the reasons to keep the Electoral College in the and so on. So this is the text generated by AI, and this is the text generated by human. So if you check the AI score of these text. So let me so here you can check the AI score. So let's suppose this is our text. So let's suppose here we will copy this and write this here. So this is the online tool which is stealthwriter.ai. So here we can check the AI for this. So this you can see this text is likely to be written by human. So and if you copy this text, let's say if you copy this text from here, and if you check the AI content of this, So here you will clearly see that the text is likely to be written by AI. So these are the text which are written by human and written by AI. So we will be building a model for predicting what are the text written by human and what are the text generated by AI. So let's move ahead. So I hope it is uh, till now all the points are clear to you. So moving ahead, so let's print some information of the data with the help of df.info information of the data. So df.info will provide you the information about the data df.info. So the info is like we have the two columns text and another one is generated. So the text column contains 48 40 4 lakh 87,235 rows. So one is object and other is float. So all the features or class variable contains non-null value, and the total number of values are 4 lakh 87,235. So this is the text, and let's move forward. Yeah, let's count the value of each classes. Counting value of each classes with the help of let's suppose our classes is generated generated generate dot count value. With the help of value count sorry value counts. With the help of value counts we can find the number of classes. The number of classes zero, which are 30,000, 3 lakh 5,797, and the classes which are corresponding to AI generated text are 1 lakh 81,435. So you can see there is a large difference between these text. So I am not going to balance this data, as this data is imbalanced. So I am not going to balance the data set. I am just doing other pre-processing task. Like in the pre-processing task, the data pre-processing. So in the data pre-processing, I have done some pre-processing like removal of stop words, removal of punctuations, and removal of tags. Removal of tags like new line tags or other tags. So this is the data pre-processing technique I will be using. So you have questions that why we will be doing that, like what is the need of removing stop words, uh, what is the need of removing punctuations, and what is the need of removing tags. So basically the need of doing this is so the basically need of doing this is to enhance the quality and effectiveness of the text analysis. So here, like if for removing the stoppers, stoppers like the is in and that usually carry less meaning. So they contains a less meaning and are frequently used and are frequently used in the data. So basically, these stoppers like such as they is in and they that usually carry less meanings and frequently used in data here. And you have seen these stoppers many of the time, and these stoppers the removal of these stoppers can reduce the noise from the data, So this helps in focusing on more meaningful words that contribute to the context, and this helps in dimensionality reduction, so reducing the number of features in the data set, which can improve the efficiency of the which can improve the efficiency of the algorithm. So first, it helps in it helps in reducing noise and dimensionality reduction, and improve performance. So this is the reason why we are removing stoppers, and for removing punctuations such as commas, period, like punctuations such as commas, periods, like periods are dot periods, and exclamation mark, exclamation points. So these do not contain any, these do not add any semantic value in the text analysis uh, analysis. So this the removal of punctuations helps in simplifying the text, like makes the text cleaner and more uniform, and reduce the complexity of the data set. So the removal of punctuation helps in simplifying the text and reduce complexity of the model, reduce complexity. So this is the reason why we are removing the removing removing the removing the punctuation. So, and also for text, and one another is contraction to expansion. Contraction to expansion. So basically, we are expanding the text which are written as contracted, like don't. Don't is written as do not. So as or do not, and can't. Here and somewhere you are saying can't. Can't is written like this. So for this we can use cannot. Why we are doing this? We will be using we will be like saying the consistency expanding contraction ensures that different form of same word are treated similarly. So different form of words can be treated similarly, and so we will be using contraction to expansion, and to improve the accuracy of the tokenization and word counts, as contracted forms may not be properly used, may not be properly recognized or matched. So here I can see I will the need of the need to expand contraction to expand, the need for contraction to expand is because consistency, uh, which ensures that different forms of the same word are treated similarly, and improves the accuracy of tokenization and word counts. So this is the data pre-processing techniques I have used. Removal of stoppers such as the, is, in, and that usually carry less meanings and frequently used in data. So it helps in reducing noise, dimensionality reduction, and improves the accuracy. And another one is removal of punctuations. So punctuations such as periods, exclamation, commas, and points do not add semantic value in the text analysis. The removal of punctuation helps in simplify the text and reducing complexity. So likewise, uh, removal of text and contraction to expansion, such as don't can be written as do not and cannot can't be written as cannot. So the need for contraction to expansion because consistency which ensures that different forms of the word are treated similarly and improves the accuracy of tokenization and word. So this is the data pre-processing. Let's do the data pre-processing. So first let's count the number of words in each text. So let's make a new column total. Df total is equal to df text. We are applying we are calculating the length of each text. So with the help of apply function, apply lambda, and x is a string. So x is a text and len x. So this is the df dot head. So df dot head, and here you can see the total and the this is our text, and the total length of this text is 3289. This is the text. Transportation is large necessity in most, and so on. And this is the length of this text is 2738. So this is the total length of the text. And now do data pre-processing. Let's perform data pre-processing. Data pre-processing. So first we will be removing tags. So let's make a function def remove tags. Remove tags. This function accepts a text, and in the text we have some tags like new line tags n, and here we have another tag which is like this. So and for tag in tags and text, we will be replace that tags. We will be replace that tag with the empty value in the text, and we will return text. And so let's apply this remove text function to our original text. Df text dot apply remove tags. So this is removing the tags, and next is removing the punctuations. Let's remove punctuations. So for removing punctuations, I am importing the module string. Import string. Import string. This. So here it is the process done. So our tags are removed. Now let's remove our punctuations. So for punctuations, I have imported a string module above. So string. So string if you print a string dot punctuation. So these are the punctuations you are seeing here, comma, exclamation marks, double comma, and hash, dollar. These are the punctuation marks. So I am removing these punctuation marks from each tag. So I will be making a function that remove punctuations. Punctuation text. So new tag, and let's suppose our new text is equal to x for x in text if x not in string dot punctuation. String dot punctuation. So here you can see like this. So let's suppose you have a text t is equal to I am Aditya. So this is the punctuations like this. So if I be printing like if I am be printing like x or x in t if x not in string dot punctuation. So here you can see I am, and here you can see all the question mark are removed. And if I join these join dot and like the help of join function. dot join. So if I join this, so I am getting as I am Aditya, and you can see all the question marks are removed. And if I put here some exclamation mark dollar, so all these will be removed from this text. So here we are doing like this. So new text we are splitting first for removing the punctuation and joining the new text. So new text is equal to dot join new text. So this is our text and return the new text. Return new text and applying in our text. So df text is equal to df text dot apply remove punctuation. So it will remove all the punctuations from each text. So this is our punctuation removal, and we will be we will be in contraction to expansion. And our next is contraction to expansion. This is the removal of removing punctuation and remove remove and contraction to expansion. Another is contraction to expansion. Here, the removal of punctuation is done, and the next is contraction to expansion. So in the contraction to expansion, I have already written. So a and so and for am not and aren't for are not can for cannot. So this will be anywhere in the text, like so, short words are written like this. Can't have, so cannot have can't have will be replaced by cannot have, could not couldn't replaced by could not, and didn't replaced by did not, and likewise. So these are the contraction to expansion words. So I have already written. So let's write the code for it. So def I will be making a contraction to expansion. So def I will uh, I will make a function. Let's make a function onto expansion. This function takes an input as text. If we will be checking if the type of x is string. So if the type of x is string, then then only we will be doing contraction to expansion. Otherwise, we will not do. So for key in contractions. In contrast, we will be matching for each text with the for each character with the contractions key. So value equal to contractions key, and we will be replacing x with the we will be replacing key with value corresponding corresponding to the key what the value is. So we will in the text we will replacing the value key to the value, and we will return x. And if it is not a string, we will be return x. Right? So if I have a I could not, I couldn't, and I could not write. So this is my text. So let's suppose D, and I will pass this text in contour expansion D. So here this gives us this. So replace. This is the function replace. So I could not write. Here you can see I couldn't write, and this is the expanded form I could not write. So with this, let's transform our text. Df text is equal to df text dot apply lambda x on to x expression. So this is our text. Let's let's run the cell. Let's wait for the. So we have expanded our short forms like doesn't it doesn't is replaced by does not. So this is done, and now our next target is to separate. Now our next step is to separate x and y variable. So x variable are the features. So x variable our feature is text, and y variable is our class. So our class is generated. So these are the features and so these are the features and variables. And let's the next step is to uh, I, where, so our next step is word embeddings. So word embeddings I have told you in previous videos, and the technique and I have discussed one technique which is TF-IDF factorizer, which converts words to numbers. So I am importing from feature selection from sklearn dot feature extraction import dot text import TF-IDF factorizer, and from for training and testing data for splitting of training and testing data, I am importing from sklearn dot model selection import train test split. So basically, what we do is machine learning. So we kept some data as training data, uh, and the remaining data as test data. So basically, we will be so for machine learning model, we will we have re we require some data to train the model. So basically, if we have whole data set, so for the whole data set, we split the data in such a way that a large portion of data can be kept as a for model training, for and some data kept as uh, testing the data while after training the model. So so for that generally for train data set, we ha- we kept as 80% of the whole data, and for test data set we kept as 20% of the whole data. So so let's run this cell, and first convert our TF-IDF. So first convert our words into numbers, TF-IDF. Let's make a class of TF-IDF factorizer, object of TF-IDF factorizer, norm equal to L1. So basically this is the normalization which imp- uh, which uh, which enhances the accuracy or uh, speed of the model. So let's fit our x variable. So TF-IDF dot TF-IDF dot fit transform x. So pass the variable x. So basically this fit transform method is to first fit the data into TF-IDF and transform the words into numbers. So this is basically whole whole functionality of this fit and transform method. So let's run this cell x is equal to TF-IDF dot fit transform x. Data is converted into vectorized form. So let's split the data into training and testing set. So for this, we will be using train and test split, and this function return a tuple of size 4. So basically, this return x train, x test, y train, and y test. So this this is the output written by train test split, and in train test split we pass the x variable and y variable, which are features and target variables, and let's say test size basically denotes the what are the size of the test we are going to take. So let's suppose I am going to take 20% of this, 20% of the data as test data, and remaining 80% of data is used as train data with for training the model. And let's say random state is 42. So, so basically, X10 is our training features, and X test is the testing feature, and Y train is the training class, and Y test the training. Y test is the testing class. So let's split the data into X train and X test. So if we print the shape of the X print X train dot shape X train, or print Y train dot shape Y train. So you are seeing that uh, our Uh, Xtrain dot shape is the number of rows in the data, 3,89,788, and these are the features. Like here you are seeing the features like 55,15,482. So these are the features in the Xtrain. So this is the feature, and let's train our algorithm. So I have taken two algorithms as logistic regression and support vector machine. So for logistic regression. For logistic regression, let's first import logistic regression from sklearn library, sklearn.model linear model. So so sklearn. So logistic regression is come under the linear model. So this is the linear model of logistic regression, and we for for checking the performance of the algorithm, we use different performance metrics such as accuracy score, classification report, and confusion matrix. So this is the I am taking it from here. I'm taking it from here. So here you can see I have imported logistic regression class from linear model, and for performance metrics I have used accuracy score, classification report, and confusion matrix. So I have made a function run logistic regression, and I have passed xtrain, ytrain, xtest, and ytest. In return, this function will give TF, IDF, and classification. So our classification is logistic regression with some parameters as penalty L2, C, C is a hyperparameter 1.0, and tolerance value 0.1. And I have fit the training data into classification, fit with the help of fit method, xtrain, ytrain, and predict the y with the prediction made on the testing set. So I have calculated accuracy score, y test, y predict, and the classification report of the. So let's run this. So here you can see the accuracy of the logistic regression is 62%, and the precision is 77%, and the micro average is 39%. And now another let's take another algorithm, which is SVM. So SVM. So this is our SVM classification model. So for I have imported linear SVC support vector classifier, and same for all. For performance metrics, I have imported accuracy score, classification report, and confusion matrix. And I have made a function run SVM, and this function accepts input as xtrain, ytrain, xtest, ytest, and CLF is equal to linear SVC. So this is I have made an object classification. Some I have some parameters like penalty equal to L1, C 1.0, dual false, and I have used here loss as squared hinge, and I have fit the training data into classification model and predict the value of X test. So I have calculated accuracy score and classification report and return the TF-IDF and classification value. So let's run this cell. Sorry, S test. Yeah, so here you can see the accuracy given by SVC is 99%, which is better than logistic regression, and the classification report says the precision is 99% and the macro average is 99%. So all are 99% and accuracy is approximately 99%. So this is the accuracy given by SVM, and we can select our classification model as support vector machine as it gives the better accuracy. So let's and let's say I have a text. So this is our final model. So let's do some prediction with some text. So I have a text human human text is equal to text. I have given a text, and first of all I will transform the s text into vectors and predict the value. So clf dot clf svm predict a human text. So this is the text generated by human, and the class of this is as one. So basically this is a false. So let's take another example. Let's take another example. Here is so this is our another example. We'll just put it here. A question mark. Let's print the. So here you can see the output is given as one, which is which is shown represent the AI generated text. So one for AI generated text and zero for human written text. So this is our whole this is our model. So SVM is our best model, and this is our content detector, AI content detector. So for let's summarize this project. So first of all, we have imported our required libraries and we have read the data set. And for the data set, we have two classes, 0 and 1. 0 represents human generated text and 1 represents AI generated text. So and also we have printed some human and AI generated text and the information of the data. And in the pre-processing task, we have done some pre-processing like removal of stoppers such as the, is, in, and that actually carry less meanings and frequently using data. So it helps in reducing noise, dimensionality reduction, and improving the performance of the model. And the removal of punctuations, likewise contraction of expansion, and then we have done TF-IDF factorizer, means vectorization of the text data and fit the text data into TF-IDF factorizer, and then split the data into training and testing data set and implement machine learning algorithms on the data, logistic regression and support vector machine. And support vector machines give the better results compared to logistic regression. So let's make a pickle file. So save the model into a pickle file. So uh, we can for using it further. So import pickle, pickle, import pickle and pickle.dump clf spn open clf pickle right binary. So we are opening it when right binary. Another pickle clf sorry, tfidf. if idf comma idf yeah, comma open idf dot pickle. So here pickle. So this will create a pickle file for which we can use it later. So these are the pickle file, and we can use it in our UI model. So UI in our user interface. So let's make a user interface for this model to make it finalize. So let's make another Python file. Let's say I give it a name ai.py. So this is the file. So for this, I am using Streamlit, import Streamlit as ht. So uh, if you have not installed Streamlit, so you can install it by typing the command pip install Streamlit in the command prompt. So Streamlit st.title, I give the title as AI Detector. So let's run this. Uh, let's run this. Let's run this app. So let's run this app stream. For running this app, so type a command Streamlit run ai.py. Here you can see our title ai.py. ai.py. So let's for this we will be taken a input. So we will need a input. So st.text st.text our text area. So store in it a variable input. So input. So user input st.text area. So let's run this file again. st dot is our file. Here we save. So we need to give a label for this. So let's say label will equal to enter dot text. Enter your text now. Let's run this. So here you are seeing some. We will enter here our text, and now our final step is to predict the output. So for prediction for output prediction, uh, so we have our text. So for this text, we will be doing some transformation, like we have removed some punctuation, stoppers removal. So for this we will be doing in this also. So let's make a function called let's make a function called. So for this we have I have used uh, I have used as a clean. This is the function clean text. Clean text is a function. So this function removes the tags, punctuations, and stoppers, and another is contraction to expansion. So last is contraction to expansion. So I will copy it from here, contraction to expansion. This is the dictionary contraction. And copy this. Let's the text. written text. So this is our text. So here is our clean text function. And now let's add a button. So if our input is, if someone 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 gives the input, so if our input is not empty, so if our input is not empty, st dot write our input is this, our input. And for let's suppose input, so we will pass it into clean text. And then we will be we have opened TLF. We have up we have loaded our classifier and TF-IDF factorizer. So then transform our input into vectors and result and predict our result, clf dot text. Let's run this application again. This here chat GPT and copy some prompts. So this is our final. So let's some text from here. Let's copy this and paste it here and hit enter, control enter. So here you can see. So here you can see that your text is generated by AI. So this is the simple application which can detect AI detector, which can detect AI. And if you give a human generated text, human generated content like this. So let's copy this. Let's copy this. This may give accurate result, but let's see. Hit enter. Your text is generated by AI. So let's suppose I am doing some mistake, blah blah. So let's enter. Okay, let's here you can see that your text is generated by human, and our text is I am Aditya and boy. So here you can see us here we build a simple AI detector tool with the help of machine learning. And this in this project we have used Streamlit to make our UI. And for classification we have done some pre-processing and then factorization of the text and then modeling of the text. So uh, for uh, for this video, so that's enough for this video. And I hope you so if you like the video, make sure to hit the like button and share with your friend. And subscribe for more machine learning and data science content, and share it with your friends. So we will meet you in next video. So till then, keep learning and keep practicing. Bye bye.